So good morning, good afternoon, or good evening, wherever you are in the world. It is my great pleasure to welcome you to the 6th International Congress on Information and Communication Technology through Zoom on behalf of ICICT 2021 and Global Knowledge Research Foundation. As every one of us is passing through unseen circumstances due to COVID-19, we wish everyone and their families a safe time. Further, with immense happiness, I would like to share that we have received an overwhelming response this year from across 90 countries, where 1,150 papers were received and 350 papers were accepted, contributing to the success of the conference. The papers will be published in 4 volumes this year. We are thankful to all our guests present on the platform to join us digitally for the conference in these unpredictable times and make this conference more fruitful in terms of technical knowledge, and hope you'll enjoy the 2 days of knowledgeable and interactive sessions. Right, before we begin, I would just quickly like to introduce our chair for today, if my screen will load up. Sorry about this. Here we are. So our chair for the technical session today is Sheng Lung Peng, who I'll just give you a bit of background knowledge on very quickly. So Sheng Lung Peng is a professor and the director of the Department of Creative Technologies and Product Design at National Taipei University of Business in Taiwan. He received a PhD degree in computer science from the National Tsinghua University, also in Taiwan. He is an honorary professor of Beijing Information Science and Technology University in China and a visiting professor of Ningxiao Institute of Science and Technology. He is also an adjunct professor of Mansoor University in India. Dr. Peng has edited several special issues at journals such as Soft Computing, Journal of Internet Technology, Journal of Real-Time Image Processing, International Journal of Knowledge and System Science, MDPI algorithms, and so on. His research interests are in designing and analyzing algorithms for bioinformatics, combinatorics, data mining, and network areas in which he has published over 100 research papers. So our chair today is very much qualified for this. So to begin with, she's just joined now. So to kick things off, well, I'll wait for her to. So to kick things off, we have Irina Arhipova, who will be doing smart platform design to improve poultry productivity and reduce greenhouse gas emissions. Can you hear me, Irina?
Yeah. Thank you very much. And
thank you. I'll hand over to you now.
Now I try to share screen and show my presentation. Yeah.
Please do. Good luck.
Yeah. Now I can start. Yeah. Sorry.
Yep. Go for it.
Yeah. Okay.
I'll let you know after 10 minutes because you've got 12 minutes. So after 10 minutes, I'll let you know you've got 2 minutes left. Okay. And then yeah. Right, good luck.
So do you see now my presentation? Sorry, do you see my presentation? Excuse me. Is it possible to see my presentation?
Yeah, we can see it. Sorry.
Excuse me. Yeah. So thank you, Mr. Chairman, dear conference participants. And I would like to present this research titled Smart Platform Designed to Improve Poultry Productivity and Reduce Greenhouse Gas Emission, that is developed by the research group from the Latvian University of Life Science in collaboration with IT company Viadots. So the objective of this research is to analyze the existing smart poultry management system that allow to take a decision for the most appropriate feeding process and the lowest gas emission levels for egg and broiler producer to enhance productivity, reduce disease, mortality, and to take care of the environment. So the following proposed tasks are defined to analyze this typical data source in poultry farms and the factors that can affect poultry productivity, then to analyze research direction and technologies related to smart poultry management system, and as well to identify the challenges of implementation of the smart platform designed for poultry productivity improvement and reduction of greenhouse gas emission. Of course, now we have a lot of different multiply IT managed systems that are proposed by companies and organizations for poultry producer. And typically, this management system have multiple components and are built using three-layer architecture: the sensing layer, transmission layer, and application layer. Sensing layer involves multiple Internet of Things component, such as video cameras, temperature sensors, humidity sensor, and so on. And the transmission layer provides functionality to transmit the data collected by sensor to certain management software for decision support, which is located in application layer. Another research direction related to poultry sector is to product traceability solution using feed, QR codes, sensor and data transmission layer, for example, mobile data network. And cloud computing has been proposed as viable solution to overcome certain limitations that appear using sensing, transmission, and application layer in large farm. And now agricultural robotics is another field of research which incorporates all three layers. And at the present moment, robotics focus on monitor of environment condition in farms using various sensors, or evaluation of chicken health, egg picking, and chicken movement. So smart poultry management system are crucial component of modern poultry farm, and such system can help decision-making process to reduce cost and use of resource in production. And implementations of such system typically include technologies such as sensor usage, process optimization, and data-driven decision-making platform. Published research shows that computer vision and machine learning in poultry farming is applied to solve tasks of detection, identification, classification, and prediction. And as demand for production is increasing, one of the typical tasks where machine learning algorithms and the computer vision are used is prediction of broiler weight. And animal health detection in another task. For example, there are studies that applied the support vector machine to classify sick broilers and the computer vision system to identify sick broilers. So the previous result shows the example of different IT solution to detect on the early stage the problem in poultry farming for its productivity increasing. But there is a lack of information of multi-criteria decision-making approach using in poultry production. Usually, the decision process consists of the following stage: problem identification, structurization, model development, criteria selection, and determination of weight to a criteria. And as a result, the best solution selection between the alternatives. And it is necessary not only to develop the most appropriate feeding and keeping process and the lowest level of gas emission, but also to reduce disease mortality and to take care of the environment. It means that it's necessary to develop the multi-criteria decision model for the best solution selection with respect to the following criteria: to maximize productivity or reduce disease and mortality, and to minimize the level of gas emission. So proposed platform is designed with the main task in mind to allow for precise manipulation of feed recipe by analyzing existing data, to identify the effects of different feed recipes on the productivity, and identification of additional factors which affect productivity, such as seasonality and disease. So estimate greenhouse gas production based on manipulation with feed and other factors, seasonality aspects, or detection of disease, and etc. And as a result, a producer will be able to optimize this feeding process, enhance productivity, and reduce disease, mortality, and to reduce carbon and ammonia emissions. Of course, there are certain challenges that need to be addressed in real world development of the platform. The system must be adaptable to its only functionality needed. The system must be cloud-based solution, which allows the farmer to have a little IT investment. Usability and visualization of data is critical for the system due to the fact that main user will be farmer and they have less experience in use of IT solution. System must provide support of file formats that are used in the field for data exchange and possibility to add manual entries. And as well, there should be implementation of data visualization and estimation model to reduce greenhouse gas emission. So within a project, it was concluded that it's necessary to create a new data analysis tool based on machine learning algorithms in order to achieve better efficiency result in the production of egg and the broilers. As a result of the analysis of data collected by sensor, it will be concluded which nutrients produce the largest emissions. Sensor data acquisition has been done in real time and stored in MySQL database. And each poultry factory has been equipped with 3 pairs of sensor. On the next slide, you see the plan of real Latvian poultry factory that consists of several barns, which divided into types, cage-free and caged egg-laying system. At poultry second house, where 2 pairs of sensor is placed on each floor, birds can move freely, while at poultry first house, where only 1 pair of sensor has been located, belongs to the cage type. Due to the fact that ammonia belongs to light gas, while carbon dioxide to heavy, then ammonia sensor is located at the top of the room, while the carbon dioxide at the bottom. And of course, to prevent damage, device must be placed off the reach of the birds. The next case is Estonian. It's a neighbor country near the Latvia, near the Baltic Sea. This farm consists of several poultry houses. It's different construction where the birds are located depending on the life stage, and the sensors has been located at 2 houses. You see that one of this house is empty due to the disinfection because the new flock of birds will be moved in April 2021. So Latvian poultry factory has been equipped with 1 central data accumulation analyzer and 1 switchboard, while Estonian factory with 2 sets of them. The analyzers and switchboard has been located outside the poultry house in a separate room, and the sensor have been linked in 1 chain, which is connected with centralized gas detection system. And this detection system supports the combination of gas sensors and display an alarm when gas level has exceeded a programmed limit and indicated which sensor has detected it. On the next slide, you see the summary of different data types that have been analyzed. It consists of 6 different...
Sorry to interrupt, you've only got 2 minutes left.
Okay, 2 minutes, yeah, it's enough, yeah. 6 categories related to the bird age, weight, mortality, laying, then feed intake, recipe, feed conversion rate, as well water consumption, temperature inside, outside, humidity, eggs, number, category, weights, and housing type. And you see that there is a difference between different type of housing system when, for example, for cage-free laying system, laying productivity is less than standard despite the caged egg laying systems, and when laying productivity is close to the standard. And the next slide shows a different situation for egg weight. The another productivity factor where the opposite picture when a cage-free laying system shows better results than a cage egg laying system, as well as relation between weight and temperature, because due to the fact that when temperature increasing, then are also egg weight decreasing. Yeah, so you see that a lot of different productivity factors that have another result depending on housing system, and it is necessary to take a multi-criteria decision on how to increase the productivity of egg and broiler producer. So, and as a conclusion, poultry farm existing solution typically provide a hardware solution, and this solution allows to manually entering data to generate reports with certain exception where automation such as egg counting is implemented. Machine learning in poultry farm is applied for identification of animal health, detection of behavior, and forecasting tasks. And in order to reduce of ammonia and the greenhouse gas emission, as well as to develop the most appropriate poultry feeding and keeping, and to increase poultry productivity, and at the same time to reduce disease and mortality, for the best solution, it is necessary to develop and apply the multi-criteria decision model. And the main task of this proposed platform is analysis of data to identify the effects of different feed recipes on the productivity, and identification of additional factors which affect productivity and lower level of emission at the same time. Thank you very much for your attention, and I'm ready to answer if you have any questions. I hope that
Great, thank you for that.
yeah.
If anyone has any questions, if anyone has any questions, put them in the chat box. But if not, I'll just hand over to the chair, who I imagine has some questions. Can you hear me, Shane?
I need to check to chat. Yeah, okay.
Well, that's just if someone sends questions, but if not, Shane, the chair, should be asking some questions, hopefully.
Yeah, so I didn't see in chat any questions. No.
No.
Yeah.
Okay. Shane, do you have any questions to ask? No. Okay. Well, that's fine then. So we'll move on to the next presentation.
Yeah. Thank you very much. Yeah.
That was me. So moving on, we should hopefully have Alma Casas-Farustu, who is presenting Deciphering Consumer Behavior Through Emotions Using Neuro Marketing. Are you there, Alma? Start when you're ready.
Hi everyone, I'm Alma Casas. Then I will present the topic, Deciphering Consumer Behavior Through Emotions Using Neuromarketing. Marketing helps companies link their objectives with current and potential customers, needs and preference to learn more about customer or consumer behavior. That is why, to know the reactions of the market to the different marketing actions, companies have traditionally resorted to their analysis by conducting surveys, the following being the most popular: market research, customer satisfaction surveys, purchase analysis, lead generation surveys, product inspection, advertising inspection, price elasticity of product segmentation, product testing, and market. In this technique, the most common is that the potential customer tests the product without commitment. This helps to facilitate the decisions in the realization of growth dynamics or focus. This consists of bringing together a group of people. It is directed by moderator and with a structure developed by him. Its principal function is to evaluate various aspects of a product service, the different uses or possibilities that it could have based on the perception and observation of the group participants, among other research activities. But these methodologies focus on knowing the conscious behavior, while the consumer's buying behavior is fundamentally unconscious, part of the fundamental principle that a behavior is the result of a neurological process and manifests itself through the neurological system, to the way we use our five senses to turn our experience into process of both conscious and unconscious thoughts, because the ability programming lies in our neurological activity. How the humans have a brain and a nervous system that allows them to perceive their surroundings. These systems allow to think and feel decided behaviors. Emotions play a fundamental role in this process decision process. It is very evident that our process they do not mark a definite and clear emotional state, since they are significantly more evident in complex processes and high involvement by customers. Or at least they are more perceptible. Ekman found that there are a series of expressions that are universal and occur in both Western and Eastern world cultures. Ekman states his basic expressions in 1972: anger, joy, surprise, disgust, sadness, and fear. Currently, new technologies develop a greater interest in applying the methods of neurology in various areas other than medicine, which relate to the human behavior. Neuromarketing is the study of the functioning of the brain and the neuron in the nervous system. It provides the knowledge and essential tools to understand disease of the system. It is one of the ways to investigate and understand consumer behavior and making purchasing decisions, thus supporting us to better understand psychological behavior and dictate actions more accurate for marketing based on knowledge of brain reactions. The nervous system is defined as the system through which the human being receives information about its environment through its senses, processing said information and using responses. There are methods to measure emotions in the processes of consumer purchasing decisions: body language, emphatic design, and eye tracking. What is neuromarketing? Braidot determines that neuroscience seeks to understand the functioning of the sensory system of the brain according to the encoding of information from an external panorama. That is how the nervous system performs the conversion of large amounts of stimuli to which an individual is exposed to brain language, activation and disactivation of neurons, interaction among neurons, emission of information manifestation, and neuroplasticity. Neuromarketing is commercial marketing communication file that applies neuropsychology and neuroscience to market research. Although neuromarketing does not will offset traditional marketing perspectives, there is great certainty that functional magnetic resonance is a tool needed. It will allow increasing the highest performance in the formulation and implementation of brand strategies of the brand, and the diffusion is recognized that have a significant impact on consumer preference for products. 1020 system is a prestigious standard method used for extracranial electrode placement. The 1020 numbers make reference to the 10 and 20% of distance in which the electrodes on the front occipital, right and the left sides of the skull. Each point has a letter to identify the lobe and a number identify the location of the hemispheric. The letters mark the area of P prefrontal, F frontal, C central, P parietal, T temporal, and O occipital. While the numbers designing the hemispheric right, even, left, out, and the middle electrodes are marked with a C, the of C in frontally in the middle. Magnetic resonance imaging fMRI. The terms magnetic resonance imaging from fMRI refers to a method that performs an anatomical sample of the brain through magnets. It is carried out using an fMRI scanner to calculate the degree of the oxygen in the blood, indicating an increase in brain activity in some specific regions. The measurement is carried out as follows. The magnetic field can identify the blood's oxygen content in the brain. Therefore, whereas neural activity is increasing in a particular area of the brain, the blood increases mainly because the brain needs oxygen to perform its function. Regularly, the consumer purchase process is understood as the set of developed steps with the eventual backward returns until reaching the final decision translate into a purchase. There are numerous proposals in this regard. However, most coincide with the following phases: awakening, identifying, or recognizing the needs, collation, and processing of information, formulation and implementation of the election, including assessment of consequences. Emotion and key
We have 2
factors
minutes
of
left.
marketing. Because the person
What?
Sorry, I was just saying you have 2 minutes left.
The internal
Yeah,
factors
continue. I was
are
just saying there's 2 minutes left.
okay. The internal factors are the most important, for example, emotions, as a high impact axis for the marketing purpose. Neurology and neuromarketing. The limbic system focuses on learning, memory, and a large part of emotions. And the reptilian system specializes in regularizing and intellectual behavior. The cortex management, the process associated with the thinking and reasoning. Neuroscience and neuromarketing. The rise of neuromarketing has advanced significantly in predictable market research, showing how feelings and unconscious responses influence customer decisions, perceptions, and determination. The main techniques used, research using neuromarketing is carried out with the help of equipment that until recently was only used by medical science. The following are the most frequently used procedures: positron emission, tomography, functional magnetic resonance, imaging, transcranial magnetic stimulation, galvanic response, eye tracking, facial electromyography.
Neural network. Artificial neural networks are a model of processing and machine learning inspired by the way the nervous system processes. It is a system of a linkage of neurons that participate among themselves to the execute and output stimulus. Materials. Broadband Muse is a headband which will help us perform an encephalogram and obtain bioelectrical signals from the brain. The headband consists of 7 dry sensors, 4 input channels, and 5 output channels facilitates access and use of brainwave data. Detections in encephalogram. An encephalogram can detect a series of specific frequencies grouped into frequency bands associated with a particular area of the brain or with the particular activities, the type of signals emitted by the brain capable of being detected by encephalogram. The waves of brain detects for encephalogram is gamma, beta, alpha, theta, and delta. Encephalographia protocol. Process is carried out by collecting the electrical process of the cerebral cortex using surface electrodes. The received signal is minimal that it becomes necessary to use various amplification systems. The amplifiers used are differential obtain an electrical impulse of 2 points and amplify the difference of the way the electrodes are placed on the head is subject to the International System 1020.
Alma, you really need to start wrapping it up soon.
What?
We need to wrap it up. You've gone over your time.
In conclusion, neuromarketing's best application predicts consumer behavior. The consumer says things that do not always coincide. Therefore, if artificial neurons are applied in neuromarketing for market research, this will generate relief results. This is the reference. And that's all for me.
All right, thank you very much for that. If anyone has any questions, please just write them in the chat box. Does the chair have any comments? Is he still here? Yeah, Sheng, do you have any comments? Any questions?
No. Thank you very much.
Okay, that's fine. Right. Okay then. Well, 1 second. Yeah, thank you for that, Alma. So moving on.
Thank you.
We have Ala Kirthi Reddy, if I've said that correctly, who will be presenting emotion detection from text using LSTM. Are you here? Yeah.
Is it visible?
No, it's not at the moment. No, I can't see your screen. You need to click share screen. It's at the bottom of the page. It should be like a green icon.
Yeah, now it is visible.
It says it's screen. Yep, there you go. All good. You're ready to go.
Yeah. Hello guys, I am Kirti from India. I am pursuing BTech final year in KL University. I am thanking ICICT for accepting our paper entitled as Emotion Detection from the Text using LSTM. Yeah. 1 second. These are the list of contents which I am going to elaborate in this PPT. Abstract, objectives, language processing, emotion estimation, software requirement, challenges, experiment result, conclusion, and future work. Yeah, at first I want to define what is an emotion. Emotion and feeling of these words may seems to have the same definition, but if we go close to those words, the clarity is not the same as what I we think. I will differentiate the both words. Feeling, we will all experience both emotion and physical sensation. From example, we may feel cool because of the weather, and similarly, we may feel emotionally feel cold too. Emotion, we can feel emotion through the emotion experience in our life. Emotions are conjoined with the thoughts, action, experience, and beliefs, and these are the different types of emotions: loving, playful, foodie, annoyed, happy. I'm giving a brief information about what was the paper did on emotion detection from text. We can say that we can express emotion in different ways: speech, facial, and text-based emotion detection from the text is a relative new classification task like. People use text messages for the communication. Text analysis have allowed the area of emotion detection to come a recent interest in the field of natural language processing. Human recognition emotion usually, but the problem is in for mission. Mission need accurate algorithm to recognize the emotion from text. There is still a question on how to detect the emotion from a text. To solve this problem, this paper is generated on emotion detection model to extract the emotion from text using LSTM is nothing but long short-term memory. And the LSTM model detect the emotion from a text input by searching the direct emotion keywords from that input. To make the decision more accurate, emotion affect the bearing the words and phrase were also analyzed the got an accuracy of 84.4%. And the main objective of this application paper detecting the emotion from a input text by searching direct emotion keywords from the input. To make the decision more accurate, emotion affect the bearing of words and phrase were also analyzed. For this paper, it is an implemented on NLP task of creating a model to detect the emotion from text. We will develop this using the PyTorch library. Detection the emotion from text, we developed this using PyTorch library. We are created our deep learning neural network using the word embedding LSTM and fully connected layers. The methods from the emotion from a input text by searching the direct emotion keywords from the input. To make the detecting more accurate, emotion effect bearing words and phrase were also analyzed. We implemented an NLP task of creating a model to detect the emotion from text. Coming to here data set, the data set is consists of 132 instant, whereas testing phase has 56 instant. Each sentence contains the maximum 10 words. In this paper we worked on glove data set. In the glove file we have a pre-trained word vectors values. Each line of the text file contains a word followed by n numbers. The n numbers describes the vector of the word position. N may vary, depends on which vector. For this paper, N is 50. Since we are using the gloves.56b.50d, first creating a dictionary that word to vector map will hold the map between the words and then amending vector of those words. Here we are using a loop for each line in the file and splitting the line by every space into each of the components. After splitting the line, we can make the assumption that words does not have the space in it and set it is equal to the first and elements of the splitting line. Then we can take the rest of line and convert into a number array. This is a vector of the word position. Finally, we can update the dictionary with the new words and its corresponding vectors. Here we detect the five emotion creating of loving, playful, happy, annoyed, and foodie, and we labeled from 0 to 4. Loving is labeled as 0, playful is labeled as 1, happy is labeled as 2, annoyed is labeled as 3, foodie is labeled as 4, and we append these emotion and emojis. In the training phase, we erase the previous granted, making a prediction, calculating how much we missed. figured out and weights and missed the changes those weights correspondingly. While testing, the face contains a label for the each sentence between 0 to 4 corresponding to 5 emotion. Finally, we test our model with any sentence, and all the words are gloves embedding flow only. The text file is in gloves.6b.15d file. The function is about to read glove file. In the glove file, we can pre-train word vector values. Each line of the text file contains a word followed by n numbers. This is the architecture of emotion detection using the text. This model is based on the keywords. Uh, spot spot technique. Apart from that, it is also used the concept of ontology. Using of ontology makes this model more effective, as the methods recognize the emotion from the input text. The framework is divided into main components of emotion ontology and emotion detection. Ontology is an explicit specification of conceptual ontologies having the definitional aspects like high level schema and entities and attributes interrelation in between. Entities domains vocabulary allows a program to specify in an open, meaningful way the concept of relationship that containing characters of some domains. Emotion is expressed as joy, sadness, angry, surprise, hate, fear, and so on, since there is a not any standard emotion. More focus is on the related research about emotion in cognizant in cognizant. The emotion of the text documents can be recognized with the help of this emotion detector algorithm. The emotion calculates the score of the every emotion classes of a primary level available in the emotion. Score is declared as an emotion of the input text document. Here we are using the NLP task is nothing but natural language processing. Occurring in text is at a one or more level of analysis for the purpose of an human like language processing for a range of task application. NLP task of creating a model to detect the emotion from text. We will develop using of PyTorch library. NLP is an representing a natural occurring text at one or more levels. Analysis for the purpose of achieving a human-like language processing for any range of in a task application. NLP has two major methods of analysis: keywords analysis or pattern matching technique, and synaptic driving parsing technique. Matching in giving a set of keywords and any input. Strings we need to find all the instance of any keywords. The input string 1, label as 1. The keyword set must has a 2. Properties non-empty and finite. The set of keywords to be non-empty is necessary since pattern. Matching by definition can't be performed against. Having a many applications such as parsers, spam filtering, digital libraries, etc. Synaptic driving is a parsing technique for the addressing these difficulties in syntax directed parsing. The input part of program is constructed automatically by meaning of the standard algorithm from a high level description of the input data structure coding to prefer any required process of in data is attached the description of convent way. Next, coming to the example, we taken one example. Wanted some oil for his bicycle. In this sentence, oil is a noun. Another sentence, this is an oil painting. Here, oil word is an adjective. In these two sentences, we observe the same word oil is acting as a noun, and the first and adjective is in second sentence. So that we don't know that how that the oil is used until we read the whole sentence, so that we have the determined parts of speech of relevant particular context. Here semantic and its understanding as the study of meaning covers the most complex task, like finding the synopsis words and disintegration, and constructing the question answer system, translating from one NL to another. And basically one need to complete the morphology and syntax analysis before trying to solve any semantic problem. Emotion estimation.
2 minutes left.
Okay. detecting emotion state of a person by analyzing a text document from the him or her appearance. Challenging the both also estimation many times due to the facts that most of the times textually. Here we are using the two frameworks: word processing model, sentence analysis. The model named as sentence analysis, which is an easy but a lengthy process. We use the LSTM, long short-term memory, as a specified form of RNN capable of learning long-term dependence, typically only called LSTM. LSTM is designed to avoid the issue of long-term dependency. It is basically their difficult behavior to remember details over long period of time. LSTM helps to retain the error of the back propagated across the time and error. They allow the network to continue learn our many strategies by maintaining a more constant errors. LSTM containing the data is great seller beyond the normal recurrent center. It's splitting the sentence into the word. For each word, adding the index, amending the layer, converting our tokens into an amending of specific size. LSTM layer, defining the hidden state or dimensions and number of layers. A new type of RNN called LSTM have been developed. LSTM is a additionally state called as a cell state through which the network make the adjustment in the information flow. The advantages of this state is the model remember to forget the learning more selectively. And the at step 6, the LSTM is based on the deep recurrent neural network model with the dropout layer was used as a constant model to verify the flexibility, and the softmax is used for the activation function for multi-class classification problem where the class membership is required one or more two labels. This is the which was the flow chart following. And we use the software requirement: Python, WordKit library, OpenCV, Google Colab, Jupyter Notebook, GitLab. These are the applications which we helpful. And the software engineering, website customizing, and gaming. The emotion detection is a techniques used to read the emotion on a human face by using the high-tech image processing software. The program can recognize the emotions such as angry, sadness, fear, joy, surprise, trust, and so on. The power digital advertising. The power of emotion detecting to understand the emotion for their potential customer, to improve the customer experience, and to create a lost bonding. To begin with, analyzing various facial experience and behavior helps to figure out the emotion state of a customer. This is a subsequently help to recommend the product that satisfies the customer. These are the challenges. One of the biggest challenges to determine the emotion is the context dependence of the emotion within the text. A phrase having the elements of angry without using the word angry or any of synopsis. For example, the phrase shut up. The another challenge is in difficult that other components of NLP are facing, such as word sense designation and co-conference resolution. It is difficult to success rate of machine learning approach without first trying. These are our experiment result with an accuracy of 84.4%. For emotion detection from the text, we are unable to successfully create the model that cloud achieves an accuracy of 84.4% in our training set, and also we are able to use our model of inputted sentence, and we're able to get the expected emotion output. This is the sentence: I hate you, I annoyed, and I want a pizza foodie. Let's see the game. These are the sentence which we are taken and predicted the output. At conclusion, emotion detection is a human computer interaction can be seen as an important area of study. Researching have done enough our work to detect the emotion of an audio detail, while the recognizing the emotion from the textual data is still fresh and hot field of in this paper. Along there is an elimination method there are currently being used to detect the emotion from the text evaluated, and fresh device architecture is proposed that were more efficiently. And the further work. The future work of the emotion detection is promising, although not enough time that has spent to have the establishing the standard in the field. The algorithm consists of an increasing in accuracy. In future, we will trying to increase the resource of the lesson and the emotion dataset to increase the performance of our methods as well as increasing the accuracy of the entire system. To being able building such as an application, they are able to detect the emotion from the text and facial, enhance the human computer interaction. If computers person moods and emotion state, it could be able to switch our coordination from the interaction. Thanking you.
Right, thank you for that. Has anyone got any questions? No, okay. So moving on. Oh, Sheng, do you have any questions?
Oh, I think, natural language processing is really complicated. Yeah, in particular, I think for ironic words is hard to realize. For example, I say happy with an happy face. Yeah. So I think this result is quite good. Thank you very much.
Okay, thank you, sir.
Okay. So moving on. Next. So next we should have development of design of a low-cost air quality monitoring system in Bingjiang province. Have we, sorry if I mispronounced your name, Nyum Yen, yeah, have you arrived?
Yes.
Okay, well, I'll hand over to you. I'll stop sharing my screen.
Okay.
Please go ahead.
Thank you. Okay, can you see my screen?
Yeah, you're good to go.
Okay. Good afternoon or good morning, everyone. I'm Nguyễn Đức Thịnh. My team includes 5 members: Mr. Nguyễn Võ Tất Thuyết, Mr. Trần Quang Nhu, Dr. Võ Bích Hiển, Mr. Nguyễn Bình Minh, and I. I present for the team to present the development and design of the low-cost air quality monitoring system in Binh province. The content of the presentation include research motivation, system overview, the designs of the first and the second generation sensor node, the results and the discussion. And investigate Vietnam at 161 over 180 of the ranks, according to the report of Environmental Performance Index in 2018. Vietnam did not approach the expected requirement according to the Vietnamese National Environment Performance Assessment Report 2008. Binh province have 28 industrial parks with total area more than 10,000 hectares, with a population of 1.7 million. But monitoring air quality around this industrial zone is not considerable seriously. You can see from the map on the figure, the red indicate the industrial zones in Binh Duong. And the urban health such this effect obviously as shown in the index in the figure. Even though the number of people and the disease related to the lung and breathing problem are not listed. You can see from the figure, the air quality in Binh Duong, especially in Binh Cat, show that it's unhealthy. The index shows the pink color. The authority have organized a hackathon competition and scientific workshop about smart solution for Binh Duong New City in 2017. The monitoring air quality project was the first prize. You see, we received the first prize. All of that are our motivation to design and develop this project. Moving on to the system overview, See how it works. From the diagram, you can see that there are two layers. The bottom layers include the node, the sensor nodes. The top layer includes the cloud and the web interface. From the bottom layer, the sensor converts the physical properties of the surrounding environment, such as dirt, PM1, PM2.5, PM10, humidity, temperature, to electrical signal, voltage, and current. And these signals are connected by the central processor, then sent by the data to the storage cloud by Wi-Fi or NB-IoT connection. The data then are shown in the web interface by the air quality index. Let's move into the detail of the design of the first generation sensor node. The design criteria. The air monitoring system is small and compact. It can withstand in Vietnamese environment, no different temperature inside and outside the case to minimize the hot air effect in the measurement result. Minimum resistance of the air through the case from any directions. Electronic designs. The Raspberry Pi is the main control unit here. Particle sensor alpha-sen OPC-N2 is used to connect the data and then send it to the Raspberry Pi. The 4G to Wi-Fi modem is used to transfer the data to the cloud. Firmware. The program is written in Python and use the library SPIDF, file-based admin OPC. Python scripts start automatically after the Raspberry Pi finished putting. Now let's move to the design of the second generation sensor nodes. The PCB design using STM MCU with 10 UARTs, 2 SPIs, 2 I2C, and few GPIOs. The wireless module is S for Wi-Fi or NB-IoT. The sensor measures the temperature, relative humidity, air pressure is BME280. The sensor to measure PM1, PM2.5, PM10 is BMS7003. GPS module is used to locate the position of the node. OLED display to show the air quality index. 4G to Wi-Fi modem can be used at places where there's no Wi-Fi connection. You can see the right figure is a PCB design and the block diagram is in the left. In the block diagram, ARM Cortex-M3 is main control unit. The sensor and the wireless modules are also connected to the control unit for the data transmission. The UART1 protocol is extended from 1 to 8 ports to achieve more number of the sensor connected to the control unit. The other UARTs, SPI, I2C interface are used to maximize the number of the sensors and communication modules integrated into the control unit up to 16. The IC74HC4051 is used as a max 1 to 8 to expand the UART1 from 1 port to 8 ports. This IC can be used with both analog and digital signals. For the firmware, independent program is used to create the system counter, increasing its value every millisecond. This counter is used to determine the period of reading and sending the sensor data to the file base. Now we come to see the result and discussion. The first generation and the second generation sensor node measure 5 parameters: PM1, PM2.5, PM10, temperature, and humidity. The result of PM1, PM2.5, PM10 values show that the second modules have a sensitivity better than the first modules. The noise error of the second module is higher than the first module. Both results show the similar trend that the index value is high on the daytime and low at the nighttime when the temperature is dropped. Humidity range measure in the first module and the second module is almost the same. Temperature range of the first module and is a bit higher than the temperature range of the second module. Conclusion. The first module was designed and run successfully with the Raspberry Pi. Mechanical design shows the advance when different temperature inside and outside the case is not much. All data were collected then sent to the cloud. The second module is low cost and compact device. It is very convenient to create the wireless sensor networks from this device. The components of the device are easy to find in the local market. Thus support the mass production. OLED display to show the measure value, and its design is more stable with a real-time operating system, RTOS, and ARM-based microcontroller. NB-IoT technologies have created products with low power consumption and high coverage signal. The limitation of this design, the sensor is dependent on the humidity levels based on the sensor manufacturer specification. The long-term data need to be collected to remove the error from the change. The collect data from only one node in the same season, but in different years. Future work of this research. We will investigate by setting up 3 nodes at the same position, but in different altitude to see how the behavior of the air quality in different layer height. The nodes will be set up by close group to check the reliability of the result and stability of the second module system. That's all. Thank you for the attention.
Thank you very much for that. Anyone got any questions?
I have a question.
Yeah.
Okay, I have a question.
Yes.
In the conclusion, the result say the second model is better than the first model. I think it's quite good. Okay.
Yes.
However, in the previous slide, you say the first model is the first generation model, and the second model is the second generation model.
Yes.
In general, we usually we should know that product of a second generation model should be better than first generation model. So I think it's you mean the first model and the second model, but not the first generation model and the second generation model, right?
Yes, yes, yes.
Okay.
Yes.
Thank you very much.
Thank you for clarifying.
Right. So if the presenter of using narrative-based video on gaining safety driving, focusing on career resilience and learning style and automated driving level 3, could start if possible, please. There you are. Yeah, we can see your screen. We can't hear anything at the moment.
Okay.
Oh yeah, I can hear you now. Please do go ahead.
Can I start? Can you hear?
Yeah, I can hear you. Please start whenever you're ready.
What title or presentation title is using a narrative-based video on gaining safety driving. I'm Junko Handa. In the beginning, I will talk about my part, and later, Dr. Makiarame will take over presentation. Cabinet Office in Japan launched the first Minister of Strategic Innovation Promotion Program, SIP. The Council for Science, Technology and Innovation allocates both the boundaries of ministries and fields and aims at practical application and commercialization from basic research. This is one of the SIP programs about driving automation. This research on effective educational methods about level 3 driving automation. In the level, the driver must take over driving when the teacher requests. The research we conducted in 2019 found 2 points. One, personal resilience influences learning. Second, differences in resilience can be observed by video learning, video format. Thus, in 2020, we developed motivational learning materials to enhance the effectiveness of video learning materials. Our project focuses on the learning materials for traffic safety education and effective educational methods. Necessary knowledge and information to be acquired by drivers and pedestrians as well as effective educational methods should be identified. Furthermore, there are individual differences what one needs to know about automated driving as a driver and how to relate an automated vehicle as a driver. So we aim for diverse people to be actively interested in automated driving vehicles. In order to prevent accidents caused by human error, there is a method that classifies elements of the driver's safe driving behavior into hierarchies and examines countermeasures. This human hierarchical approach theory of driving behavior consists of 4 layers. The model was added one more layer. The current traffic safety education mainly targets up to the contents of the second layer, but in order to realize safety education in society as a whole, it is necessary to motivate them to focus on higher layers. Action model is based on the idea that
Sorry to interrupt. Would you be able to speak up a little bit, please? I'm struggling to hear a little bit.
yes. Action model is based on the idea that there are 4 key elements in the learning process. Attention is stimulating and maintaining learner's interest. Relevance is to make the learning experience personal and meaningful. Confidence is to help them to believe that they can succeed. Satisfaction is that learners should be satisfied of what they achieve. Narrative approach Andrew explains 2 important points of a structural feature of narrative. The story has time axis and is connected. There is a causal relationship between the elements that is inferred. Furthermore, she provides 5 elements as a measure of narrative. It is not the general theory or abstract theory. The characters are clear, the temporal transition is clear, There is a dramatic structure including introduction, development term, and conclusion, and the causal relationship is clear by introducing narratives related to driving automations as motivation. It may be possible to support learning beyond the restrictions of learner's ability of awareness. In this study, two types of motivational learning materials were developed. They are short video that shows the learners before they learn the main content. One is narrative, the other one is fact-based information, including data using graphs. Both materials were developed based on ARC's model in order to motivate learners regardless of their learning style and resilience. A as attention and R as reference elements were especially focused. The materials were examined if either one showed better outcome. Purpose of the study. There was no difference between the two types of motivational learning materials in the preliminary evaluation using the ARCS evaluation sheet. There is the same motivational effect on the ARCS model. The purpose of this study is to investigate the effectiveness of two types of content developed based on does including a narrative in the motivational video increase the post-scoring regardless of the level of resilience? In addition, the influence of learning style is expected during learning. In this study, we also consider the relationship between high and low resilience and the learning style.
Method. The survey consists of 4 steps: 1 pre-test, 2 personal survey, 3 learning with video, 4 post-test. The third step is divided into 3 groups. 1, a pattern A uses a narrative-based motivational video. Pattern 2B uses a fact-based motivational video. Pattern C uses no motivational video. This is narrative-based. This is fact-based. Measures. Pre-test and post-test asks the same 2 questions. A perfect score of this test is 11. Question 1 is single answer. Question 2 consists of 10 questions. This study focuses on career resilience and learning style as a personal ability. Resilience is one of the psychological chapters that improves ability to deal with negative experiences. The learning style uses Federer's 4 factors model. The number of respondents was 310 for each pattern. This table compared the average score of learners' 4 factors of career resilience. There was no significant difference between the motivational patterns. This is compared the average score of learners' 4 factors of learning style. There was no significant difference between the motivational patterns. This is the result of pre-post test. For pattern A, score increase rate of pre-post test was about 1.18 times. In this study, IBM SPSS statistic 25 is used for analysis. In this study, factor-affected learning were examined logistic regression analysis. This is the result of narrative-based pattern. Pre-test score are learning style, specifically SEN, were statistically significant. This is the result of fact-based pattern B. Pre-test score and resilience score were statistically significant. This is the result of pattern C. Pre-test score and resilience score were statistically significant. As a result of analysis, it was considered that narrative pattern most absorbed resilience. In order to confirm the motivational effect of pattern A, matching was performed by propensity score, which consists of pre-score and running style, in particular SEN. The pre-score increases in all patterns, but post-score increases only in pattern A. Conclusion. Pattern B and C were found to be impacted by resilience. Pattern A may have the effect of absorbing carrier resilience. This result is consistent with previous study on the narrative approach. Limitation. In this survey, gender, material, status, age, etc. were examined, but self-efficacy and expected results after learning were not investigated. In this study, the learning effect was tested by a selective test, and in order to investigate the degree of comprehensive more accurate, it is necessary to consider the test question method. As further research, the possibility of adaptive learning consider learning style and resilience characteristics need to be investigated. As a further study, the relationship between ARC's model, evaluation item, and carrier resilience should be investigated more. Thank you. Thank you for your attention. 早かったですかね?
Right, thank you for that. Does anyone have any questions?
Okay.
Sheng?
Yeah,
Yeah.
maybe I have a little suggestion, okay, for the presenter. Okay, I think some slides are changed too quick, so it is hard to follow. So I think maybe this is a good result. Next time, hope you can have you know, some presentation, some presentation slowly, so we can easy to follow. Okay. Oh, thank you very much.
Thank you for your suggestion.
Right, thanks guys. So up next we have Jiří Mirovsky presenting sense prediction for explicit discourse relations with BERT. So please do start when you're ready.
Okay, can you hear me?
Yeah, I can hear you.
Okay. And can you see my slides?
I can't yet, no. If you click share screen at the bottom, it's like a green icon.
Okay. Yeah, share screen. Yes. Okay, what about now?
We still can't see anything, no.
Okay. Yeah, okay, just a minute. Share.
Yeah, that's fine, that's fine.
Oh, okay, great.
Yeah, there you go. All good. Good luck.
Thank you. So, hello, thank you for being here. I'm speaking also on behalf of my colleague Lucie Poláková, my co-worker. We are both from Charles University in Prague. Our work comes from the field of natural language processing, and more particularly, it concerns analysis of shallow discourse relations which basically means discourse relations as semantic relations between propositions, between sentences. For example, one sentence, one proposition can be a result of another proposition or a condition of another proposition or explanation, specification, generalization, etc. Let me give you a few examples. The first example, our association does not re-educate, it tries to educate. So the first sentence denies some claim and the second sentence gives the correct statement. So there is a discourse relation between these two sentences, and the meaning, the type of the relation is correction. So we correct something that we negated in the first sentence. It appears between two sentences, so it's intersentential, and it is, the meaning is not expressed with any word, any connective, so we call it implicit relation. We can say the same using explicit connective instead. So the same two sentences, this time with an explicitly present connective. So it's again correction, intersentential, but explicit. And our work is about explicit relations. The same can be said also within one compound sentence with a connective but in this case. So it's an intra-sentential relation this time. Let me demonstrate on the connective but also sense ambiguity of connectives. So we can see that connective but can express correction, but it can also express opposition, just two independent propositions put into opposition, like he found mushrooms but lost his fork. Or here, I smashed it against the ground about 15 times, which creates some expectation, but no, I barely scratched it. So it's the discourse sense is concession here. So our experiment is about trying to predict these discourse senses for pairs of sentences. We were inspired mostly by the recent work of Shi and Demberg, which did the same thing for implicit discourse relations using BERT, which is a successful deep learning system pre-trained for several languages, and it can be fine-tuned for a specific NLP task. So they did it for implicit discourse relations, meaning there is no connective present, and we try to do the same thing or a similar thing for explicit discourse relations. So our research questions are, can we use BERT successfully for classify discourse senses for explicit discourse relations, and we do it on Czech and English? And if we know what is the connective in the propositions, can it help to improve the classification using BERT? And third, we try to use annotation projection to obtain more training data for experiments in Czech. These are our data resources. For Czech, we have Prague Dependency Tree Bank, which is a manually annotated tree bank of the size of 50,000 sentences, annotated among others with discourse relations. For English, we have the Penn Discourse Tree Bank, again, approximately 50,000 sentences, annotated manually with discourse relations. And we also, for the annotation projection, we also have parallel Czech-English dependency tree bank, which is a translation of the Penn Discourse Tree Bank to Czech, manual translation, human translation of the data to Czech. So the third resource was used to obtain more training data in Czech using annotation projection of the discourse annotation from English. In our experiments, we only take into account intersentential, between sentences, explicit discourse relations, meaning discourse relations expressed with connectives. And we have three settings. First, we simply present the two sentences to the BERT system just as they are in the training data along with the sense of the discourse relation. And for the test data, we ask BERT to give the correct sense of the discourse relation. In the second experiment, we tried somehow pinpoint the connective in the propositions to tell BERT what is the connective word, and hopefully this might improve the results. And in the third experiment, we used the additional training data in Czech obtained by the annotation projection. If we have the two sentences, the connective usually is in the second sentence, mostly at the beginning, but as you can see, it can appear also elsewhere in the second sentence. And the system, the neural network simply doesn't know where to look for it. So the first three sentences somehow show the first experiment setting. We just presented these sentences just as they are. In the second experiment setting, we redundantly and without any linguistic meaning added the connective at the beginning of the second sentence. So it appears there for the second time. But always at the same position. And we hoped this would make it easier for the system to find the connective and use the information coming from the connective. And we have two baselines. The first of them is very, very simple. We just always predict the same class, the most frequent class, which is in both languages conjunction. The second baseline is also a simple one, but quite a powerful one. For each connective, we use the class, the discourse sense, that is most frequent for the given connective in the training data. And this proves to be a very, very strong baseline. These are our data sizes for Czech and for English. We have approximately 5,000 sentences, 5,000 cases. Each case is 2 sentences. And for Czech, obtained by the annotation projection, we also have some additional training data, again, also almost 5,000 sentences. The test data is something over 500 sentences, and number of different labels to predict in Czech and in English is 23 and 27. And these are our experimental results. So if you look at it, you can almost immediately see that the results for English are better than for Czech, although the data are of similar size and similar type. And you can also see that baseline 2 is quite successful and hard to beat. Our experiments using BERT. First setting, if we simply present the 2 sentences, that's the first BERT line. If we prepend the connective before the second sentence, we get some improvement, we get a slight improvement. But surprisingly, if we use in Czech the additional data, the results get worse. So to conclude,
2 minutes left.
Yeah, thank you. It's quite difficult to beat baseline 2, but it's a well-known fact. We can see that pinpointing the connective, even in this very simple way, helps improve the results. We've seen that English is better than Czech. The results in English are better than in Czech. And we are not sure why. One possibility is that BERT has better pre-trained models for English. Also, the data show that sense ambiguity in Czech is bigger than in English. In Czech, there were in the data there were approximately 300 connectives, different connectives, and 80 of them showed sense ambiguity. But in English, only about 35 connectives show sense ambiguity. And also, annotation projection did not help. And it may be because the taxonomies of discourse senses are slightly different in the two corpora. And also the data show that probably there were different annotation preferences for particular connectives. So this leaves some room for further study and further improvement. Okay, thank you for your attention.
All right, thank you very much. Have we got any questions, Sheng?
No, thank you.
No, okay. So up next, presenting the pragmatic idea of HCI notion and KE approach in video mobile learning, we have Neuro. If you're ready.
Okay, can you hear me?
Yep, I can hear you just fine.
Okay, I'm trying to share the screen right now. Okay, hold on.
That's fine.
Okay, can you see my slides?
Yep, all good to go. Good luck.
Okay, thank you so much. Thank you, Mr. Liam, and Assalamualaikum, and good morning to everyone. So I'm Farah from Malaysia, and I would like to share with you a portion of my research that is about interactive video mobile learning. And this one of the topics that I put in my research actually. So the pragmatic idea of HCI notions and the KE approach. So meaning to say that HCI is a human-computer interaction, and the KE is the concept engineering. So moving on to the introduction, everyone know about the mobile devices. So mobile devices has this quality of flexibility whereby it's convenient for users to access anywhere at any time. So when it comes to mobile learning, so mobile learning, it enhances the availability and the flexibility for learning condition among the learners. So it's a good thing actually. So here we have what we call here is video mobile learning. So video mobile learning is a major platform. As we can see here, we are currently facing a situation where we need to have an online conference such as now. So in order for educators to provide the information to the learners, they opted for video mobile learning. So it's safe to say that video mobile learning is a major platform. So even though the video mobile learning has become the major platform, it still has issues and challenges. But I'm not talking about the video mobile learning. I'm talking about the educational video actually. So educational video is known for having a good results and satisfaction among the learners, but still there's issues and challenges that are derived from the educational videos. So the listed one here is the one that I can see a very considered prominent subjects being discussed and issued by the researchers. So the first one is the interactivity. So interactivity is actually related to interactive elements should be included in educational video. For instance, when I read one of the study, it mentions that the learners actually looking for interactivity for the key sections to jump to the topic that they want to focus on first. So that one is being issued by one of the researchers. Which quite intrigued for us to actually explore more on that area. So it helps to, and another one did mention about the cognition process level, because not everyone has the same cognition process level. So it helps when we have the interactivity, we provide the user control to learners actually to choose to decide which one they want to learn first. So moving on to the multimedia elements, okay, lack of diversity in media can limit the information process. So what you can see here, for instance, currently I'm doing the audio and then I'm provide you the slides with the graphic and text. So the elements that I use here, even though I have the video cam on, but it's all about me talking, nothing animation, no animation and so on. So imagine if I have these animations elements included to demonstrate the information that I would like to share with you guys. So it helps to enhance and your understanding on the topic that I would like to deliver. So currently, some of you maybe feel like don't get what. Okay, so we have the visual effects and compositing design. So visual aesthetic influence is actually important because it helps to give moods and boost up some of their motivation to watch the video, make them feel engaged. So there's another one research mentioned about it helps to set the objective of the learning purpose. So visual aesthetic actually has its own influence toward the educational video. And then the information arrangement and video sequences. Actually, this one is related to the interactivity as well, because it's about the subdivision. The best to have, one of the study mentioned that the best to have subdivision instead of the constant animation. So the continuous video is actually take a lot of effort for learners to watch the video and try to understand the content. So it's best for us to, the educators to create a subdivision, give some small portion for them to digest the information before they're moving on to another part. And then the video timeline, again, this one is actually related to the arrangement and video sequences and then the interactivity as well. So this, one of the researchers mentioned that the best time duration is actually around 0 to 3 minutes. Why? Because that is the best time to hold the attentions of viewers to watch the video. So next slide is about interactive video mobile learning. Since we are talking about the issues and challenges, and one of them mentioned about the interactivity, why is it important to have a choice in one single video timeline? So this idea is directly getting from the information arrangement, video timeline, and then the interactivity. So combining them all, why not we just create one video, okay, one video timeline, maybe about 15 minutes, but then we create partition in that single video timeline into small portions. So for example, I'm taking the example of today's situation whereby the lecturer have to provide a video for chapter 1. So in chapter 1, we have several topics that they need to deliver. So they will share the video for chapter 1, and then the video continuously play until the end of the chapter 1. So why not we try to create partition in that timeline? For example, this topic that allow the learners, the students to actually click, tap on the, because we are talking about the mobile devices, tap on the buttons, and then it will jump to the intended topics that they want to focus on first. So why is it important? As you can see, the current video mostly on linear video style, which is we only have the video and then the teaching and learning. And then we have the non-linear, is about interactivity. We apply interactivity here. So this one actually have in the YouTube platform. Unfortunately, YouTube platform is only, the time point features that are available on YouTube is only for desktop and laptop. For mobile devices such as tablets or smartphones, the time font feature is still not available yet. So I already tested. I already uploaded my video, and then see and try using the smartphones. So the numbers that I set over there is not activate. So moving on to the pragmatic idea. So I'm trying to construct, I'm trying to apply the HCI notion, human-computer interaction, and then construct the user interface to enhance the user experience. So again, from the issues and challenges being provided, I try to solve by looking down each of the issues that being subjected in the studies. So key points as the key sections. So I have to create another platform for smartphones in order for me to implement the pragmatic idea for HCI notions. So multimedia elements used creatively, enhance the visual interface, and so on. We have lessen the burden. That is the most important. We need to lessen the burden on the cognitive process. So the information arrangement should be arranged properly. So the aim of this study is to see whether the interactive video mobile learning able to get the response, a good response from the learners, how well they engage with the interactive video mobile learning. Will that will that give a positive feelings response toward the application itself? So as the methodology, in order for me to apply the pragmatic idea of HCI notions, I need to create a prototype for smartphones. So a prototype here, I have to use the mixed method, that is a video production process, and combined with the ADDIE method approach in order for me to develop an application for interactive video mobile learning. So Kansai engineering, I use as a measurement proxy to evaluate how well they respond to the prototype. So we have the level as shown in the slides. And then this is the conceptual analysis design. So before I proceed, I need to check the conceptual, I need to look into the conceptual design, what kind of video production style that is suitable for learners. And then after that, I have to measure the effective value and the cognitive value in order for me to look at the T&L quality improvement of that product, which is for my prototype. So if there is an improvement, so meaning to say the production value has have a good production actually. So now a new directions of IVML. So IVML is a short form for interactive video mobile learning. So this is the prototype that I developed for Android platform. So we have the video over there, and then there's a button for them to opt for the topic that they want to focus on first. So IML, TNL, video, which created the IVML. That is the basic tree. At the end, we have the IVML. So the survey and findings. So this is the general survey that I conducted to see what kind of response that they get. So they mentioned that if we focus on the aesthetic value, and then if we have that interactivity, 70% of them mentioned that for aesthetic value itself, they feel motivated and they feel more understand. They have a good comprehension to what the topic presented. As for video timeline, which is related to the interactivity, 68% agree that it helps to boost up their motivation and their understanding toward the topic. So I actually
2 minutes left. Sorry to interrupt. 2 minutes left.
Oh, sorry. Okay, thank you. So about 150 respondents involved in here. So I tried to narrow down to show you how the experiment being conducted. Actually, there are 3 samples. The first is the prototype. The second one is the videos that I got from the YouTube. And then, so I'm going to show you the results. This is the prototype, the one that I developed. So it shows the positive response, feelings toward the prototype itself. And then these are the video, which is quite considered as a linear video, not considered, it's actually a linear video. There is no interactivity, but there's a visual effects because the one who developed it used the green screen effects. So still good, but then consider moderate. And then we have the moderate feelings, which is, it's a linear video with no visual effects. The screencast means that the one that I'm doing right now, without any effects behind me. You only see me talking to you. So that's the screencast. Sorry. Okay, so contribution. The contribution, a new directions to interactive video mobile learning, modernizing the TNL classroom activities. And the second one, it supports the KE validity. The KE is being widely used around the world among the researchers, especially in Japan. I think, not I think, it's being widely used because the founder is Mitsuo Nagamachi. So, they're used for manufacturers in order to see how consumer look into the product design, how well they receive the product design of that product. So for the educational video, the KE is not being widely used yet. So I try to use this KE approach for educational video and see what happened. So actually it gives a good results. So as for conclusion, the area of interactive video mobile learning actually is a vast and have a potential in its own area. So it's good if other researchers try to look into this prospect aspect. I mean, to go furthermore, because currently we only have the basic control, which is play button, stop, next, and so on. So it's good if we can directly interact with the video, allow them have something like they can communicate with in offline style, something like that. But that's my opinion actually. Hopefully there's a way for that, a breakthrough for that. Thank you, Mr. Liam. So any question?
Yeah, thank you for that. If anyone has any questions, Cheng, if you have any questions. Cheng, did you have any questions?
No, thank you.
No, okay. Right, well, so that was our last presentation. So I'll just quickly say a few words very briefly before we go. Share my screen. So very briefly, I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of the International Congress. I hope the session was informative and knowledgeable. All the presenters will be getting their digital certificates through the mail within 2 days. Further, all the papers have been forwarded to the Springer. Publication will be live within 4 to 6 months. I'd also like to thank our chair, who we have made a certificate for. So we'd like to thank Sheng Lung Peng for chairing the session. In fact, this is just a token of our appreciation on behalf of the ICICT 2021 and Global Knowledge Research Foundation. Before we go, guys, if I could just get everyone to turn their cameras on very briefly, just so I can take a screenshot so we can put on our website, if that's possible. If you haven't got a camera, don't worry, it's fine. Any more cameras to come on? Oh, got another one. Okay, right, I'll just take it. Oh, is that another one? One more, okay. Anyone else? Right, I'll just do that. Right, there you go. Right, thank you, everyone. Cheers, bye, guys.
Bye-bye.